Hello everyone, I am your friend Shadab Imam and I brings you an example on how to construct a network diagram, and this will help you in network construction in CPM and PERT. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So let's move on to the problem, and this is our problem. So before going to the problem, let us have a recap on the rules for network construction. So the first point says that no two activities should have the same starting and ending event. This means that no two activity can have the same starting and ending event. So if this is activity A, this is activity B, so both this activity cannot have the same starting and finishing event, and this can be eliminated by using dummy activity. The second point says that the activities are put in a logical sequence based on the precedence relationship. So precedence relationship has been given in the table, as it has been given that activity C is preceded by activity A. That means that activity C cannot be started until activity A is completed. So this sequence has to be followed logically. And the third point says that if needed, use dummy activities to show the logical relationship. So in order to eliminate this condition or some other logical errors, we can use dummy activities for network diagram. Now each activity is represented once and only once in the network diagram. That means among all the activities given, every activity can be represented only once in a network diagram. And the last point says that there is only one starting and ending event in the network diagram. That means if for all the events who are not having any precedence, they need to be start from a starting node, and all the open activities at the end of the project has to be terminated at the common node. So let us start solving. So in this question, first of all, we need to see that how many activities are unpreceded activities. That means they are not preceded by any activity. So we can see that activity A and B are unpreceded activities. So first of all, we will construct activity A. This is activity A and this is activity B, and this is the starting node. Now moving on to activity C. Activity C is preceded by activity A only. That means once activity A is completed, activity C can be started. So let us see here. Suppose this is the finishing point of activity A. Once this is completed, activity C can be started. So we can see that this is activity C. And now activity D. Activity D is preceded by activity B. That means once activity B is completed, activity D can be started. So let us start. This is activity D. Now activity E. Activity E is preceded by activity A only. That means from this event it shows that activity A is completed. So we can start activity E from this particular event. Similarly, activity F is preceded by activity B. So again at this node only activity B is completed. So activity F can be started from this node. Now moving on to activity G. Activity G is preceded by C and D both. That means to start activity G, activity C and D has to be completed. So what we will do is we will converge activity C and activity D to a common node, and this node suggests that at this point activity C and activity D are completed. So we can start activity G from this particular node. This is activity G. And activity H is preceded by activity G and activity F. So activity H is preceded by G and F. So we will bring F towards activity G and we will converge these two activities at a single node. So this node suggests that activity G and activity F are completed at this point of time. Now activity I is preceded by activity E. So we will select this, that if activity E is completed here, activity I can be started from this node. Okay, then activity J is completed by activity H and activity I. So we forgot to start activity H as it has been preceded by G and F. Now activity J is preceded by H and I, so we will converge these two to a single node here. So activity H and I are converged at this node, and this suggests that at this point of time activity I and activity H are completed here, and we will start activity J from here. So this is activity J, and now activity K is preceded by activity J. So we can see once J is ended, activity K is started. Now there are no further activities, so we will see how many open activities are there, and we can find out that only activity K is an open activity. So we will conclude this open activity to the final or terminating node. Now this completes our network diagram, and to number the event or numbering of event can be done using the numbering of event rule, which is given by Fulkerson. So let us see how we number these events. Now first is the initial event, which has all outgoing arrows with no incoming arrows, is numbered 1. That means the starting event has all the outgoing arrows and no incoming arrows, so this event will be numbered as 1. Now delete all the arrows coming out from the node 1. This will convert some more nodes into initial nodes. Number these 2, 3 and so on. So we will assume that the outgoing activity from this particular node are deleted, and now after deletion of these activities there are 2 initial nodes appear, so we will number them as 2 and 3. Now delete all the arrows going out from the numbered events to create more initial events. Assign the next numbers to these events. Now we will delete the outgoing arrows from the numbered events. So 1, 2, 3 are numbered events, so we will delete these outgoing arrows, and after deleting this we can see that these two are becoming initial events, and this is not yet an initial event because there is still an incoming arrow is coming here. So this currently this is not an initial event, but these two have become initial event once activity A, B, C, D, E and F are deleted. So we will number them as 4 and 5. Now again what we will do is we will delete the activities going out from these numbered events. So activity G and I are also deleted, but so this will become an initial event, but this will not yet become an initial event as activity H is still an incoming activity. So now this will be number 6, and continue until the final or terminal node, which has all arrows coming in with no arrows going out, is numbered. So we will continue this procedure till the last or terminal node. So again we will delete all the outgoing arrows from the numbered event. So after deleting all these arrows we can see that this will be our initial event, so this will be number 7. Similarly, once this is deleted, this is number 8, and this will be number 9, because this is the final or terminal node and no arrow is going out from this node, all the arrows are coming in only. So now we have completed our network construction, and we will do some more examples to learn how to construct typical networks. So if you like the lecture, please share the lecture. Have a nice day. Thank you.